Hello guys, welcome back. I'm your friend in Excel. Right now I was a little bit boring because I have probably learned too much of the mathematics. Now, let's go back to the reality. You know, the math is a good one to increase your mental world. I don't know, but those people think that if you are good in mathematics, you are also be good at the knowledge learning. But that's not true. By only knowing the math will not help you to build any real software. You have to also know the programming. And for the programming, basically, you got 2 points. You have to split it into 2 parts: the user interface and the data multiplication. Let's say the data manipulation, right? So today we are going to learn the second part, which is the data manipulation. Let's say how to read that correctly.
Data manipulation.
Here we go. Data manipulation. Sorry, let's.
Data manipulation.
Data manipulation.
Data manipulation.
Manipulation. All right. And to be able to do that, basically, you at the first you need to learn how to operate on a database. And for the database, there basically have 2 kind of stuff. The one is called the SQL-less database, or they call it no SQL database, for example, the MongoDB. And we are already quite familiar with that kind of database, but we may not be familiar with the SQL, although we use a lot of SQL Lato or MySQL, but I don't know this one. They say that this is the best. I don't know, so I'm gonna try it out. The world's most advanced open source relational database. Yeah, then you say what he mean. They say that this is the most advanced database. Can you believe that? I don't know. So let's get started to use this database. Let's say how can we do that. So at the beginning, we need to actually download one. For my case, I have a MAC OS, so I'm gonna use this one. Alright, there has a lot of ways to install this database, but I prefer to use a homebrew because if we use this method, we could do it with just 1 line of code. Yeah, here we go. This is the one that we are going to use. Bro, install PostgreSQL. I'm gonna copy that. And probably use that right in here. Let's say if we got it correct or not. Okay, so to start the PostgreSQL. Okay, this is the name for this database. At least we need to know how to read it first, right?
PostgreSQL.
PostgreSQL. All right. Then it says that if we want to start it, we need to run this line of code. No, I indeed need one. So let me do this. It says that successfully started the PostgreSQL at somewhere. All right, then what's the next? After we have installed and started the service, the problem left is that how can we use it? So at the beginning, we need to get started. We can cover the installation or whatever, but I'll just get into the creating a database. Okay, here's the command that we could use: create database mydb. Oh, I can't believe that we can really run this command from everywhere inside of a terminal. That's something that I don't know. Alright, then let's say what else we could do. If you do not want to use your database anymore, you can remove it. For example, the drop db my database. Alright, then what's next? After we have successfully created a database, what we need to do is to access that database, right? So how can we do that? We could say PostgreSQL with the len of your database. So PSQL, then with the len, which is my DB. And here we go. We just got into the let's say the database we created before. It says that we could type the help for checking the help documents. And after we did that, we could use the edge to look at the SQL command or the mask, let's say the question mark for viewing the PostgreSQL command. Let's use the edge first. Oh, as you could see, there doesn't have that much command that we could use. There are just a few of them. Or maybe not, there has a long list of it. For now, if we want to create this mode, we can just press the Q, I guess. Yeah, that's correct. Then how about we use this symbol? Well, why can't I see anything? Oh, okay, here we go. There still has a lot of things out there, but to be honest, I don't care, since I don't know. Maybe that's too much for us. And here we go, the SQL language. Well, no matter what kind of SQL database you use, they basically have the same language, just there has little difference between all of those. So normally you could master the SQL by theory if you know the basics. So for example, how can you create a table? You use this command, right? You use the create, which is a command. Then table is also the command. The weather here, it's a len of that table. Okay, let me do some playing with it. Before I create a table, I'd like to just first do it in the way I am. Then I'll copy all those commands into the database. So at the first, we need to create a table, not weather, but something else. Let's say people. At the first, it's the len of that people, right? And it's the age of that people. This is probably the command. Fine, I don't care. And the last one is the date. It's probably the created date or create data. Some people, when they design a database structure, they would like to ignore the past tense of English. They will ignore all those things, but just use the simplest one. For example, here is a created date or delete date, something like that. I don't know why, but they prefer to do that. So this is our database for now. I'm gonna create a table by using that. And here we go, we got no errors out there. That was awesome. Then how do we know which table, or how do we know how many tables that we have for this case? We got a command called show tables. Then let me show that. We get an error, unrecognized configuration parameter tables. Why? I don't know why, but it's kind of different than other database. You have to use this command. And then after that, you say, here we got a table called people, and it's owned by me. Good. Then we could insert some values into our tables, something just like this. So we're gonna insert into the people's table, the table of people, with a value of, first we should give it a len, for example, hero who. How about that? Then the age of that, it's always 18, young forever, right? Then we're gonna give it a data, which is when it is corrected. The 0.8. Now how about we do this? Okay, it seems to be correct. Let me do this. We're gonna insert it into our database and we get it right in there. After that, how can we say what kind of value we have from that table, or what's value inside of that table? We could use this command, select everything from the table. Let me do this quickly. Select everything from the table of people. Then we got the name, the age, the created date. That was nice. And we can even choose to select which clone that we want. For example, we could choose len from the people table. In this case, we would get the hero who. Nice. And after that, let me go. Oh, we could even do some filter about it. For example, now if I add another people, Christine, it's probably older than me. How about 25? And we, oh, sorry. And we're gonna insert it into our database. After that, you say we got 2 records out there. And how can we do a filter? How can we do a filter to get the results that we want? Or how can we use a filter to get the data that we needed? So we could select everything from the table of people where the age is equal to 25. We do not use an n here for the simplicity reason. So right now, if I do this, we would only get the Christine, 1 record out there. So it's quite nice. This is basically the basic idea of the database. Here's another concept called joins between tables. What is that? Thus, so far, all queries have only accessed 1 table at a time. Queries can access multiple tables at once or access the same table in such a way that multiple rows of the table are being processed at the same time. Queries that access multiple tables or multiple instances of the same table at one time are called join queries. They combine rows from one table with rows from a second table, with an expression specifying which rows are to be paired. For example, to return all the weather records together with the location of the associated city, the database needs to compare the city clone of each row of the weather table with the land clone of all rows in the cities table and select the pairs of rows where these values match. This would be accomplished by the following queries. So we're gonna select everything from the weather table and we're gonna join the cities if the city equal to the land. Okay, so this is kind of, let's say, complicated than before. For this case, we are going to create another database. Oh, sorry, another table. So how can we do that? We're gonna create another table, let's say 6. At the first we got the len, right? Then we have to give it another one called 6. And it's also a string. Okay, I guess that's it. That's what we want. But now we could create something like this, or yeah, let's create something like that. We got a syntax error. Well, that's unacceptable. We shouldn't get any errors out there. Alright, now we got it right. Yeah, after that we need to insert some data into it. For me, I am a male. For the Christine, she's a female. So basically we got two records out there, and we insert it, we got it correct. There has no errors. Alright, then let's use this query command. So what we should do is to select everything from the people table while join the 6 on the len equal to len. The first len was existed on the people table. The second len was existed on the 6th table. I hope you understand that. If you don't, let me just run this line of code very quick. We got an error. Clone reference len is ambiguous. Oh, that's something that I didn't expect. Alright, then let me just do some experiment with it. So for the first one, it's belong to the people. For the second one, it's belong to the 6. I don't know if that's work or not. Let me try this. Oh, it's working. So this is the final result that we got. We get the len, we get the age, the created data, the len, the 6 at the same time. That was good, but there has only one problem, which is that I do not need 2 len out there. So what we could do here is that we need the people.len, we need the age, we need the 6.6, and we need the people.createDat. Alright, let me try this out. Oh, we still got an error. So it's probably related to the create data. We should use a capitalized character or not. Oh, we still got an error out there. Oh, I know that we should replace the. Oh, let me do this. We should replace this A with a E. Yeah, after that we should be fine. This is the final result that we got, which is just something that we want. Nice try, buddy. Now let's go on. What else that we could do? It says now we will figure out how we can get the high word record. What is that? Back in, what we want the query to do is to scan the weather table, and for each row to find the matching cities rows. If no matching row is found, we want some empty values to be substituted for the cities table's clone. This kind of query is called the outer join. Well, should it be called the default join, since we somehow gave it a default value, even if it's an empty one? Let's say select all from weather left outer join cities on weather.city equal to cities.len. Okay, the two things should be equal. And what the left outer means is that they will try to fulfill the left table, which is a weather table. If it doesn't have such a thing, it will be replaced by an empty value, I guess. I don't know. This query is called a left outer join because the table mentioned on the left of the join operator will have each of its row in the output at the least once, whereas the table on the right will only have those rows output that match some row of the left table. So the left table is a boss. It cannot be changed. It will always be fulfilled by the right side of tables. Oh, you know what? We could even change the clone len by using the ask command here. For example, let me try this out. Well, how they did it? Oh, I got it. So actually, when we do the select, if we if we do not put this symbol and this symbol in our commands, then we'll get something more intuitive. For example, the first row would be the clone names for our table. And then we could do some changes for it. For example, I could say the people.createData as that. By doing so, we should get a new clone where the clone name has been changed from the created data to data. Oh, sorry, date. That's probably how they read it. Dates. It's always hard to distinguish the data and the dates.
Date.
Date. Alright, date. Alright, let's continue. We got so many different stuff to know. And for this one,
Aggregate.
Aggregates. Aggregate functions. I have no idea about that, to be honest. You know what? For my ADO Davis configuration, they also have a stuff called Aggregate Davis. I have no idea what is that.
Aggregate.
Aggregates. So let me do a rating. Like most other relational database products, PostgreSQL supports aggregate functions. An aggregate function computes a single result from multiple input rows. For example, there are aggregates to compute the count, the sum, the average, the maximum and the minimum over a set of rows. As an example, we can find the highest no temperature reading anywhere with something like this. If we wanted to know what city or cities that reading occurred in, we might try something like this, but this is wrong. Well, so how can we do that? We can select a city from the weather table where the temperature, lowest temperature equal to select max temperature from the weather. Okay, that's kind of duplicated, but let me try this first. Again, we'll be just using the people table, and from there I'm gonna get the max of the age. Let's say what we could get. Oh, we get 25. And how about the minimum of that age? Yeah, it's 18. That's correct. Hey, you know what? For this line, for those lines of code, I don't know what kind of situations that we would really need use those lines of code. But I know this one, the keyword of like. This is very important. This is very important for us. For example, let me do a copy, and let's say we can go to here. We're gonna select everything from the people table where the len is like the let me say it's where the table has a who inside of that string. Yeah, I guess this is enough for us. Oh, we get an error. Oh, it says that it's begin with S. Let me say. Alright, this is probably the solution for us. Let me try it out. So we're gonna edit this symbol at the beginning and the end of that string. And let me try it again. Okay, here we go. We got it correct. Nice try, buddy. Yeah, since we know after this long of learning, it's probably a learning, I don't know. It has no difficulties for me. After we know how to query data from our database, the thing left for us to do is to update some data, right? So how can we do that? We can use a keyword called set to do that kind of thing. For example, if I want to change my age, what I could do, I could say update people, where I'm gonna set the age to, I don't know, maybe set it to 0. I was never born, and I was never existed before. That's kind of interesting. Now where the len equal to hero who. I think this is what we need for updating that stuff. But before we do that kind of thing, let's say this is original data that we have, and we're gonna do an update. Oh, sorry, we probably get some error. All right, let me do the update very quick. Yeah, we got it right. After that, we choose the table again, and you will notice that my age was changed from 18, has been changed from 18 to 0. That was great. And after the update, one thing that we need to know is how do we delete a thing. It's also very easy. We just have to use a keyword called delete. But normally we won't delete any data in our database in real life, in real software, because that's dangerous. We would only, you know, for example, if that table has a clone called deleted, then if a user deleted their account, we will just set it to 1, and that's all. And nothing special about that. But now, what left here is called some advanced features. Do we really need to get into that? Probably. I guess the most important one as an advanced feature is called the foreign keys. By doing this, you don't have to repeatedly create a lot of clones. All you have to do is do a reference. For example, the where table city could be a reference of the city's land, something like that. But it's very common to, you know, for example, for user system, we would let them have an ID, right? It could be some numbers from 1 to, let's say, to infinity, for example, n. And the ID is something identical, cannot change over time. So no matter what kind of other table that we create, we will always use this clone, this ID as a primary key, or I say we will use this ID as a reference across so many different other tables, something like that. It's also not a very hard concept to understand. Let me say, everything that related to the programming, at least for me, it is easy. But if we are talking about the mathematics, at least for now, it's not that easy. But it's something that I could have done if I put a lot of time on it. Yeah, I personally believe that. All right, that's it. So, inside of this video, we have learned about how to use PostgreSQL with its own shell tool. And this is very important for you to get into it as a beginner. Maybe later you will learn some new stuffs, for example, how to use a certain programming language to handle the PostgreSQL database. But this video is still very essential for you to get started with it. So I hope you enjoy this video, and if you like it, please subscribe and doing whatever you like. For example, make a comment. I don't know. And that's it. I will see you guys in the next video. Goodbye.